see, get rid of that. Okay, here we are, 9-3, day 2. Okay, we're still going to be doing that rapid repeated integration by parts, but there's going to be a little trick in today's, and it's called reassociate factors. Reassociate is going to be the trick today. What that's going to mean is we're going to steal something from the U column and slide it over to the DV column so that it makes DV something that we can integrate. So we're just jumping right into examples. We'll have x cubed times the cosine of x squared dx. So you define your u to be the x cubed, and you let your dv be the cosine of x squared dx. And remember, the dv has to be something that you can integrate. And if you look over here, before you start doing derivative here, I'm getting too far, over here, if I try to integrate this, I didn't need the dx, but I just want to put it here because it's going to be a little bit complicated. In order for me to integrate this to sine, I have to have the derivative of the angle attached to the dx. So the derivative of the angle is 2x. I'm good to put a 2 there, but I'm not good to add an x here. But if I look over here, I have x cubed. That's an x times an x times an x. So what I'm going to do is steal one of these, this is the reassociate, and associate it over here. So I'm not going to let u start out being x cubed. I'm going to let u start out being x squared, and my dv is going to be cosine x squared with an x stolen that I'm going to stick next to the dx. Now this is something that I can integrate. So I'm not starting with that information, but I am starting with this. So derivative here is 2x. The integral here, again, you don't need the symbols. If you can see it in your head, just go ahead and do it. The derivative of the angle is a 2x. I've got the x because I stole it from the u column. I still need a 2, so I need a 1/2. So now the integral will be 1/2 sine of x squared. Okay, I'm going to have to integrate again because this derivative is not to 0. But again, I've got that same angle, so I've got to steal again. So what I like to do here is draw a line to show that I'm not using these two terms. I'm going to start over again. So I'm starting over. I'm going to steal the x, put it over here, so that leaves just the 2 here. So right now, I still have all of this plus the x that I'm going to steal. So 1/2 sine x squared, and the x that I'm stealing from there next to the dx. Now now I can integrate that. So here, I still need a 2x. I did the x. I could have stolen the 2, I guess, and slid it over, but I'll just add a 2 and a 1/2. Yeah, that would have left a 1 there, but that's okay. So now derivative here is 0. Antiderivative here is going to be 1/4. Remember, all constants carry along. And then what has sine as its derivative is a negative cosine. Okay, and then there's my 0, so I know I'm done. Now, be careful that you do want to show when you reassociate that you're starting over, because on your diagonals, this is where I started. But I'm not going to use this one because I reassociated, so I started here again with my u. So when you have that bar, you're going to skip over it to draw your next diagonal. And then here's my horizontal integral, which is going to go away because it's a 0 anyway. But positive, negative, positive. So my integral will be positive 1/2 x squared sine x squared. This will be a negative times a negative 1/4 times a 2. That'll be a positive 1/2 cosine x squared. Integral of 0 is 0 plus c. So in order to make this something that I could integrate, I had to steal from the u column, and that's called reassociation. So each of our examples is going to involve that. Number 2. to the 5th e to the x cubed dx. Okay, u will be the x to the 5th. dv is e to the x cubed with the dx. Okay, check this out first. In order to integrate an e to the u, remember you have to have the derivative of the u. In this case, that's 3x squared. So I need to steal an x squared from this and slide it over. So I'll reassociate. If I steal the x squared and put it over here, that leaves x cubed. And I still have my e to the x cubed with my dx. Now that's almost ready to integrate. I just have to put the 3 in the 1/3. So derivative here will be 3x squared, because I didn't use those. Integrating here, I need 3x squared. I've got the x squared. I need a 3, so I need a 1/3. So the integral will be 1/3 e to the x cubed. Okay, this is not down to 0 yet, so I know I'm going to have to integrate, so I'm going to have to steal. So I'll reassociate, draw the line anytime you steal. So I want to steal the x squared with the dx, bring down what I had, 1/3 e to the x cubed. Stealing the x squared leaves a 3 here. So now derivative of this goes to 0. Integrating here, I still need another 3. So times 3, so times 1/3. So I get 1/9 e to the x cubed. And then be careful on the diagonals. I started here. Here's my reassociate, so I jump over it. Never draw your diagonal through the reassociate. You know you're doing it wrong if you do that. Here, and then my horizontal integral. So positive, negative, positive. Again, don't have to worry about that because there's a 0. Final answer, 1/3 x cubed e to the x cubed. Here we will have minus, let's see, 3, that'll be 1/3 e to the x cubed, 0 plus c. Okay. Number 3, x to the 5th natural log of 4x dx. Again, see the x times the x, that's integration by parts. U dv. Remember, when you see the natural log, that's always your u. The x will be your dv. Because we can't integrate a natural log, but we can take the derivative of it. Okay, integrating, not a problem. This will go, add 1, I get 6, so 1/6 x to the 6th. Here, doing derivative of natural log of u is 1 over the u, times by the derivative there, so that's times by 4. That's going to give me 1 over x. Okay, which becomes x to the negative 1. Well, if I try to start doing derivative here, I don't ever get to 0 because I jumped past it. I'm into the negatives. And I can keep integrating here, so I kind of run into a problem. But if I think about this, I've got 1/6 x to the 6th. Here I've got an x to the negative 1. If I reassociate it and slide it over here, then it just combines with these x's here and simplifies. So that's what I'm going to do. I'm going to leave the 1 here. I'm going to slide the 1 over x, or the x to the negative 1 over here. So I had the 1's, and I'll write it all out. X to the 6th. And I'm sliding over the x to the negative 1. Well, if you look, you add exponents, this actually becomes 1/6 x to the 5th. So when I reassociated, I just simplified before I jumped right into derivative. Now I have no x's over here, so when I do derivative, I get 0. And now I've got to integrate this. So I add 1, I get 6. Multiply by 1/6. It's going to give me 1/36 x to the 6th. And then here we go. Diagonal. Start here. Skip. Here. Plus. Minus. Integrate the horizontal. Okay. So here I'll have 1/6 x to the 6th natural log of 4x. This will be a minus 1/36 x to the 6th. So when I ended up with x's on both sides, that's when I decided to reassociate and combine and simplify. X times the square root of 6 minus x squared dx. Okay. U dv. Since they're both x terms, you take a stab at which one you want to be u. I think I'm going to choose x. Here I'm going to make this, I'm going to write it with the fractional exponent instead. 6 minus x squared to the 1/2. Is this something I can integrate? Well, I've got an inside to a power. I can do power rule if I have the derivative of the inside attached to the dx. Derivative inside here, that's 0. This is a -2 times x. -2 is not a problem. I can't introduce an x, but I can steal this one. So I'm going to reassociate this one over here, which means I'm going to start with a 1, slide the x next to the dx, rewrite what I had. So I'm really letting the whole thing equal the dv. So that's gone. So I'm not starting with that. Derivative here is 0. So I'll be done after this. Now when I integrate this, I still said I needed the -2 times the x, so I still need a -2 here, so I need a -1/2. -1/2 times, I'm going to add 1 here, that's going to give me 3/2, so I'm going to times by 2/3. 6 minus x squared to the 3/2. And then simplifying here. So I have my diagonal and my horizontal. Positive, negative. So I will get -1/3 times 6 minus x squared to 3/2 plus c. Okay, this one didn't need to be done by integration by parts. This is one like we had before where the derivative of the inside was just here and we would slide it over and go through the integral. But if you miss it, integration by parts picks it up. So it's a good thing. Okay, our last one. I want you to be clever here. Think about it. I've got sine to the 10th x times cosine x dx. Okay, so I could turn that off. I could let the u equal the sine to the 10th and the dv equal the cosine, or other way around. Or if I think about it, think about this being a power rule with an inside. Derivative of the inside is cosine. It's right here. This is an old problem. I don't need to do integration by parts. Just like this last one I didn't need to, but I didn't look for it. I'm going to reassociate the cosine next to the dx. And I'm all set to go with the power rule. So this one's simple. Just go into sine to the 11th x times 1/11 plus c. If that hadn't happened, then I would do, if this wasn't the derivative of the inside, then I would go with my u and my dv and see where it took